Hello, everybody, and welcome to the Across the Sky podcast. If you've been following us for a while now, you know that we are a meteorology team made up of four of us within Lee Enterprises, which is a nationwide publication company. Our team is made up of myself, Kirsten Lang, in Tulsa, Oklahoma, Sean Sublett with the Richmond Times-Dispatch in Virginia, Matt Holliner covering the Midwest out of Chicago, and today, the one that couldn't make it, Joe Martucci, who is in Atlantic City. Before we get to our special guest this week, let's just first go around and chat and kind of pick up a little bit, guys, with how everyone's week was. Sean, we'll start with you. How are things going over there in Virginia?
We're kind of warm still. We're coming off what ended up being our third warmest meteorological winter on record. We haven't had really a lick of snow aside from a quick burst that lasted 2 hours back on Groundhog Day of all days. But right now we've got clouds. It's in the 60s, but you know, as we have looked at the weather pattern that's coming in March with our colleagues at CPC, we are gearing up for some much colder weather in about a week or so. So we're enjoying the warmth while we have it, but at the same time, we're also concerned about agricultural interests having been so warm over the winter.
Yeah. And, you know, the one that hasn't been warm is Matt. Matt, you have been just, I feel like, pounded with this winter weather the past week. Tell us about what's going on up there in Chicago.
Yeah, if you're keeping count, this is now the fourth week in a row where we're dealing with a winter storm in the Midwest. Now, I will say there is a little bit of a trend in that this winter storm, not as much snow. There's snow with it. But, you know, now we're starting to see more get in on the rain and the severe storm threat and the flood threat for Illinois, you know, and it's just the start of March. And we're talking about, you know, the severe weather that we've already seen in the month of February, you know, particularly in the Southeast. But now it's starting to push into the Midwest a little bit. And it's just like, oh, man, it's just the start of March. We've got a long way to go. But actually, you know what? Even though we've had these winter storms, it's been interesting because these winter storms come through and we cool down, cold front comes in, but then we warm right back up. And there are actually a lot of places in the Midwest, and partly due to these storms and all the cloud cover that we had, especially overnight low temperatures, they've been well above normal in many locations. So even though we've been dealing with these winter storms, there's still a lot of places in the Midwest that have had a warmer than normal winter, especially when you just look at the low temperatures. Low temperatures, not nearly as cold as they typically are, partly due to all these storm systems, rain, snow. But that's interesting, you know, that we're holding our high temperatures down some, but the low temperatures, there are not many clear nights, so a little bit warmer than usual.
Yeah. And, you know, as far as you were talking about severe weather, as far as that goes, I'll tell you, Oklahoma has been this past week, which we'll get into here in just a little bit with our guests. This past week was kind of it was a doozy for us. We had, well, for February, I should say, Oklahoma set a new record with 10 tornadoes. Confirmed earlier Sunday night. This, of course, being recorded on Thursday. Goodness, what's today? March 2nd. So, you know, Sunday night prior to that, at the end of February, the 26th, we had tornadoes come through, and it turned out to be a dud for Tulsa. You know, I was kind of on edge, and I was watching it, and I'm like, okay, this is gonna come. You know, I was prepared to, you know, cover that here in Tulsa. But then when it finally moved, you know, farther east, it just kind of lost its fuel. But some areas that unfortunately were not spared were around Norman, kind of central Oklahoma. And that is where our guest this week, well, not currently today, but that's where he's located at the National Severe Storms Laboratory. So I'd like to welcome our very special guest. I had the pleasure of interviewing him once before back in January, and then also meeting him in person a couple of weeks ago at an AMS meeting here in Tulsa. And I'm going to let him dive more into his biography. But first, I want you please all to welcome our newly named director of the National Severe Storms Laboratory out of Norman, Dr. Danae Carlis. How are you, Dr. Carlis?
Oh, I'm doing fantastic, Kirsten. It's really an honor to be on here with such a distinguished group of meteorologists, scientists, and of course, you know, broadcasters and journalists. So I'm excited to be here.
Well, good. Well, we are very happy to have you. You know, like I just mentioned, I was able to chat with you one-on-one for your first interview right after you were named director, and then got to meet you in person. You gave a great talk to everyone here in Tulsa. And I was kind of hoping you could kind of recap a little bit of that and just let us know first, maybe your background and, you know, a bit about how you got to where you are now as the director.
Yeah, that particular conversation was a 45-minute conversation, by the way. So I won't be able to go into all of it, but at the same time, I grew up in Tulsa, Oklahoma. Grew up, of course, Tornado Alley, severe weather alley, and my favorite kind of weather event, of course, is a severe thunderstorm, just because of the action and the excitement, the heart palpitations that you get when you see that hear that thunder and that light and see the lightning. And so growing up in Oklahoma, weather was always around me, but I didn't really know that there was a career such as a meteorologist other than being on television. And I never had any aspirations to be on television. So I kind of thought about really what I wanted to do was be a medical doctor, be a scientist. And of course, I took my first biology course, and biology kind of kicked my butt. And I was like, well, I need to rethink this biology thing. And so I stuck with chemistry because I was taking bio and chemistry at the same time. And then when I finished up with my chemistry degree at Howard University in Washington, D.C., I decided, I don't necessarily want to wear a lab coat each and every day. I need to do something that's more practical, something that impacts people each and every day. And one of my mentors, Dr. Vernon Morris, offered me an opportunity to get a free degree at Howard University, a free master's degree. And I took him up on that opportunity. I took my first atmospheric science course as a master's student and just fell in love with it, and just continued to just be a part of the field, and just study and learn how to do numerical weather prediction and build weather models. I built weather models all over the world, some in Hawaii. I built the global model, which is called the GFS, the Global Forecast System model, or the American model, people like to call it in the news. One of the developers of that particular system and that modeling system. And at some point decided that I needed to develop some of my leadership skills. I felt good and strong technically as a scientist. And so I wanted to start to think about leadership development and being in management, and being able to sit between policy, science, and of course, communication of the science. And so I went into a leadership development program at NOAA, and got an opportunity to work at the highest levels of the agency. And I got an opportunity to do things beyond just the weather mission. And I just fell in love with the impact that NOAA makes in people's everyday lives, because you wouldn't have clean fish, you wouldn't have clean beaches, you wouldn't have clean water, you wouldn't have the weather app that you use to check the forecast for tomorrow in order to make your decision about what you're going to wear. You wouldn't have those kind of things without the NOAA mission. NOAA really is, to me, the backbone of our society. And I just said this a second ago. I think the world would be very chaotic without NOAA, because we provide a lot of the information that people need in order to make decisions, in order to live a really kind of fruitful lifestyle in terms of recreation. So those are the things that kind of got me into this particular field. And I just love it. And I love the fact that I'm able to come back to my home state of Oklahoma. I've been, Boomer Sooner all of my life. I got a story about that, but I won't tell it. But, I've always represented Oklahoma wherever I've gone, from DC to Colorado to Hawaii, all of the places that I lived. I always wanted to make sure people knew that I was from Oklahoma. And it means a lot for me to be back leading the National Severe Storms Laboratory.
Hey, Danae, it's Sean in Richmond. Following up on that, I'm back in my hometown as well. And it's always exciting to be able to come back and do your career back in your hometown. I want to talk a little bit about NSSL. Our podcast reaches a broader audience, and I think a lot of folks are familiar with the Storm Prediction Center, but may not really understand what NSSL is all about. Can you kind of give a general interview or an overview, about what the mission of NSSL is?
Yeah, so the mission of NSSL is really to be the world's preeminent laboratory for observing, understanding, and modeling severe thunderstorms. We really do serve as a national resource for severe weather research, and we work collaboratively with the National Weather Service to ensure that forecasters have the knowledge, capabilities, technologies to really remain the world leaders in effectively communicating accurate, timely, and actionable forecasts and warnings of extreme weather to the public. And so when you think about NSSL, you got to think about some of the research that we do. We're a research organization. We want to have a great understanding of severe storms and develop tools and technologies for the National Weather Service. And then we also want to improve the lead time and the accuracy of the severe weather warnings and forecasts that we NOAA, National Weather Service, issue to reduce property damage and save lives. And so our research really does span the gamut. We do a lot with regards to weather radar. We study tornadoes, of course. We go out and do field campaigns to study severe weather. We have a hydrometeorology component where we study flash flooding. We also look at lightning, damaging winds, hail, and we also look at winter storms. And so we really do study all aspects of severe weather. And so we have a fantastic mission. We have amazing people that work in our laboratory, just some of the smartest people I've ever met. And I'm really happy to be there.
And Danae, what can be done to increase warning time? And from that, I mean, kind of in multiple ways. How can we get the forecast more accurate, a couple days out so we can get more specific and details? We always tell people, like, stay tuned for updates. But boy, I wish we could all get to that point where 2 days out, we can get really specific. Now, we're clearly not there yet. What do you think it's going to take us to get to that point? And then also the day of an event, how can we increase the warning time for tornado warnings and severe thunderstorm warnings? Like, what are the ingredients that we need to increase these warning times?
Yeah, my first thought when you ask that question is we need bigger computers. and I say that because, being a numerical modeler and that being my background, I feel like we've done a lot and we've advanced the state of our ability to, really understand the 5-day forecast and what that actually looks like. I started thinking globally. As I come into NSSL, I'm very much so focused regionally on that severe weather watch warning paradigm. But if you look at our 5-day forecast now compared to, 10 years ago, our 5-day forecast is probably about 85 to 90% accurate. And that's because we've gotten bigger computers. We're able to do more science and put more science into our numerical models. We collect more observations and we use those observations and assimilate those observations into our weather models even better than we have, 10 years ago. And so our modeling systems have gotten better, but that's in line with our computing getting larger and larger and larger, because when you think about that watch to warning kind of paradigm, right, that's very local. That those severe storms happen on micro scales. And so if we're going to be able to predict those severe storms, we got to have enough computing power to actually run the numerical model, such as the Warn-Off forecast system. That is a system that is experimental right now. It's not in operations. Now, that means that it's not accessible to all of the forecasters that have to predict and forecast for severe weather. But at some point, we want to make that operational and make that tool available to the wider public. And so that means people like you coming to Norman and being a part of the hazardous weather test bed and being able to say, okay, with this particular tool or technology, Danae, this is what I'm thinking about. This is how I would react if I saw this particular product. And so it takes a level of engagement from the scientist aspect to the actual user, and you all being users of information of science you have to be in partnership with us, because we need to know how do you make decisions? What are the tools and technologies that you need as an individual that puts out information that the public is actually following in order to get information, because we all get information from different places. And so it takes a partnership and a little bit of a dance between the research community and the general public and users of our information in order to create better products and services for you to actually share with the general public. And so we're getting there. And I'd love to have you all come down and be a part of that dance. And we'll continue to move the needle forward in terms of getting to a point where we can be confident in issuing like a 30-minute or an hour warning on a tornado.
We're going to take a quick break from there, but we're going to come back on the other side of that break and talk with Dr. Carlis here in just a second. You are listening to Across the Sky podcast.
On Florida's Space Coast, we think you can have the best of both worlds. Kind of like right now. Driving, at your desk, maybe at the gym, but you're also grooving to some music. Visit us and you'll go to the beach and see a rocket launch, or go kayaking and manatee spotting. It's all waiting for you on the only beach that doubles as a launch pad. Plan your adventure today at visitspacecoast.com.
Looking beyond the atmosphere, here's Tony Rice with your Astronomy Outlook.
There's a new comet turning heads, but it's still more than 600 million miles away. Comet C 2023-A3 was independently discovered in February by a NASA telescope in South Africa, and in January by an observatory in China. After an additional 50 observations, its orbit was determined, and that revealed something pretty exciting. This holds the potential to be naked eye visible, and we're talking more visible than Halley's Comet back in the 80s. The numbers point to it being brighter than first magnitude, around the brightness of easy-to-spot stars like Aldebaran and Altair. Comet hunter and astrophotographer Gideon van Buitenen did the math, and it suggests it could be even brighter due to a phenomenon called forward scattering. As sunlight interacts with dust in the coma or the atmosphere surrounding the comet as it streaks away from the sun towards Earth. There's a lot of ifs going on here, though. The comet's visibility will be highly dependent on how it behaves during perihelion, or the closest point in its orbit to the sun, a few weeks before passing Earth in October of 2024. This is when the process that heats up the surface of the comet is at its most active, exciting ices within and ejecting gas and dust, creating that coma and the comet's tail. That same energy can cause a comet to break up. This comet is anticipated by astrophotographers to come into view around June of next year, so I'm sure we'll be hearing a lot more around then. That's your Astronomy Outlook. Follow me at RTP Hokie for more spacey stuff like this.
Tony, thank you so much for that astronomy report. Once again, we are here with Danae Carlis. He is the newly named director with the National Severe Storms Laboratory out of Norman, Oklahoma. And again, I know we've mentioned that this is previously recorded. Of course, we're talking with him here Thursday, March 2nd, but Sunday, February 26th was kind of a busy one for Oklahoma in general. We had some severe storms that moved through here and some pretty strong tornadoes as well. And a couple of those were just right through Norman, Oklahoma. Now, I know, Danae, you weren't there. You're still kind of transitioning over from Oklahoma, or from Colorado rather. But tell us. I like I said, I know you weren't there, but just tell us a little bit about that experience, because it doesn't usually just come straight through Norman. Tornadoes like this.
It definitely comes through Oklahoma for sure, but at some point, sometimes it doesn't always actually have a direct impact on Norman. And we have a beautiful facility called the National Weather Center that is owned by the University of Oklahoma, and it has this sky deck up there. And so I'm sure there were plenty of meteorologists on Sunday night actually up there looking to see what was actually going on. But of course, the event happened in the evening. So me being in Colorado right now, I was actually aware of the severe weather threat based on the Storm Prediction Center's forecast, from the day before. And so I was, talking to some of my people at the office and letting them know, hey, we gotta be ready for tomorrow and tomorrow night. And, I happened to get a call or a text message from my deputy director, Kurt Hondo, and he let me know that he was okay. And we were just kind of having conversations about what was kind of going on with respect to the storms moving through the area. And he let me know he had to go into his storm shelter. And there we did have people from our laboratory that were impacted by the storm. Some, lost shingles on their roofs and damage to their homes, trees falling down, loss of power for the last few days. And I think pretty much almost everybody does have their power back. But when you look at the track of the tornado in Norman, it actually was less than a mile away from the National Weather Center. So that hits close to home. And it just lets me know that what we do is so critical for the nation. And it makes me proud that I'm part of an organization, that I work with people that are willing to put their work into what it is that we do in terms of studying severe storms, and providing that information to the public, and writing amazing journal articles on the work that we do. And so the fact that we are part of that and we've experienced that this week it really is humbling. But it also, again, makes me proud. So, yeah.
And Janae, it's Sean again. I'm a Penn Stater, but I have been to Norman a couple of times, was at the National Weather Center, and it's been more than a decade now. But can I get you to talk about some of the things that you're working on there now, whether it's hardware, software, and to increase our understanding of severe storms, something that, forecasters will be able to work with more closely in the coming 3 to 5 years, that we think is going to go a long way into helping us both understand severe local storms and prepare people better for them?
I'm probably not the expert at this, and I'm so brand new that if I say anything wrong, I'm sure my team will let me know. But the one thing that I'm really excited about is some of our work with threats in motion. It's a tool that we've developed that the National Weather Service will use, that allows the warning to actually move in time, right? And it has probabilistic information in it as well. And so when you think about a warning today, it's very much a polygon. It's like a four-sided box, basically, and it can be in different shapes, right? But when you think about the way that severe storms happen, right? They can be in like squall lines, or they can be supercells, or mesoscale convective complexes, vortices, and those kind of things. And so when you think about the movement of the storms are always moving, right? Because the weather moves, right? And when we as an entity like NSSL, we look at that from a scientific perspective and say, why are we, putting just a static box right around where that weather is currently happening, right? When that weather is actually in motion. And so the threats in motion will allow the warning to move right alongside the weather, and not in the forecaster won't have to issue, warning after warning after warning. And then you in the public will get information, because if you're just east of that polygon, you don't know what actually is going to happen. But as that storm is moving, if you get information, probabilistic information, that your threat is increasing, you go from a 10% threat to being impacted by a severe storm or a tornado to a 30, a 40, a 50, a 70% probability that you're going to be impacted by this storm. That impacts the way that you make decisions. When do you actually go and get in your storm shelter? Is it at the 10% kind of threshold, or is it at the 70 to 85% threshold? And so that the one thing that we need to do as a community is to continue to give consistent information so that people can, make decisions based on what the actual kind of what the case can be. What is the actual kind of probability that this particular storm is going to impact you and your family. And so that takes science, that takes social science and physical sciences to come together and intertwine to see how people make decisions. And it takes communication, understanding what a 10% or 50% or 80% probability means is probably very different in everyone's eyes. And so we got to communicate what that means, and so that people can actually make decisions with respect to kind of their safety. So that's one. And then the other one is the phased array radar. Phased array radar is a new technology that we've been working on probably for the last 20 years. We actually developed radar from a kind of research perspective, a long time ago, back in the 60s. That was developed at the National Severe Storms Laboratory. And so the current radars that are out there, we have over 150 across the country. They're getting old. We're going to need some new technology to come in to play here in the next 10 to 15 years. And, NSSL is playing a leading role in what that new technology will look like. And so we are doing the research on phased array radar with the hopes of really transitioning that to National Weather Service operations and across the country, because we'll be able to actually see storms develop at a very high resolution in terms of time and a temporal resolution. Right now, with the weather surveillance radars, they're called the 88Ds, right? You can only, that it spins around in a circle, and it takes about 5 minutes to actually get around and do those volume scans. Whereas the phased array radar, the resolution will be at about a 1 minute time frame. You'll actually be able to see the tornado form.
Yeah, I can't wait for those phased array radars to finally be released. I know it's been a long time coming, and when that day finally comes, I think it's just going to be just such an improvement in what we're able to do and all the capabilities. In fact, probably going to have to do a podcast episode here pretty soon on phased array radar. I think we could do a whole episode about all the things that it could offer us. But while we're on the subject of technology, and kind of tying in with the latest news and what's trending. There's been a lot of buzz lately about artificial intelligence and old ChatGPT. And I'm just curious, at NSSL, is there anything involving artificial intelligence there? Do you see any applications for it? Is there anything in the works, or maybe not right now, but in the future? Could artificial intelligence be coming in as part of your plans?
I do know that there are artificial intelligence projects related to some of the work that we're doing in NSSL, whether that be in some of the models that we develop or the technologies that we're using to create products and services, create products and test out products that would be used by the National Weather Service. I can't tell you specifically all of them because I am only 30 days in. I haven't gotten into our AI work specifically, but I know that there are projects, weather modeling projects that we're using AI and ML type machine learning type of science to advance. And I think it'll continue to be a bigger and bigger part of what we do, because when I think about AI, ML, I really think about time. I think about our ability to save time in terms of processing information, such as observations, because we collect observations all over the world, and we can't even put all of the observations that we collect into our numerical models. And so AI, to me, if AI can help to emulate and decrease the amount of time for us to actually assimilate and integrate those new observations into our forecasting system, then why not? If it continues to improve our forecast, we need to use those technologies that are advanced, that can give us save us times, which means we save money in compute, and we can get that information out to you as a broadcaster or as a public or end user of NOAA's weather information much faster.
You know, I saw something this morning about how a brewery out of Detroit was using AI to produce a new beer. And so I'm like, well, they can make beer, then, you know, they can probably do a lot of other things too. So we'll see how that all plays out. But, you know, Danae, I'm real happy you were able to join us this week. It was great to talk with you and get to, know a little bit more about you, as well as what's going over there at NSSL. So thank you so much for coming on this week and chatting with us.
I appreciate the opportunity. I got to give a shout out to my family who's been my rock. They have been everything to me. I wouldn't be the man I am or the meteorologist or scientist that I am without my wife, Lydia Carlis, my daughter, Dia Carlis, and of course, my family and friends back in Oklahoma. So I got to make sure I shout them out because they are a part of this journey and a big reason for my success.
Awesome. Well, thanks so much. And we'll hope to talk to you soon. And again, thanks for coming on.
Thank you, Kirsten.
On Florida's Space Coast, we think you can have the best of both worlds. Kind of like right now. Driving, at your desk, maybe at the gym, but you're also grooving to some music. Visit us and you'll go to the beach and see a rocket launch. Or go kayaking and manatee spotting. It's all waiting for you on the only beach that doubles as a launch pad. Plan your adventure today at visitspacecoast.com.
All right, we are back. You know, it was great talking to him. Danae Carlis is just such a nice guy. I can say, having chatted with him in person and then on this podcast, he's so down to earth. I love, how humble he is and, how much he loves where he's from. And so it's really fun to see somebody, like that, get promoted up to such a cool spot within this field and within the government,
Yeah, he's really put in the hard work too, to be sure. And I'm really excited about the new things that are going to be coming from the National Severe Storm Lab. Matt, you mentioned this before, and the phased array radars, which I've been hearing about, what feels like since I was in grad school in the 90s, as he's one of these things. It's coming. But sooner or later it will be here and give us a better idea or a better look inside the development of these severe local storms, to see them developing more in real time. As Dr. Carlis said, not just once every, radar sweep, to kind of just focus in on them and then watch them in real time. That sounds just really tremendous.
But, Danae's just another meteorologist that's behind the scenes, and I feel like that's what's great about this podcast. We're bringing you meteorologists. Like last week, we did the forensic meteorologists that you typically don't interact with. From the public standpoint, you see the broadcasters, the folks in media, as we bring you the forecast, but there's this whole sector of folks behind the scenes that are doing important work. And the folks at NSSL, some of the most important work, trying to figure out how we can make better warnings, improving radar technology, improving the computer models, which, as he said, they're getting better. And, we just slowly but surely, we're getting there to make these forecasts more accurate, especially farther out in time. We're making progress, but it's a complicated science. And so it is a slow process, but I'm glad there are people doing the hard work at NSSL to make it happen.
Yeah, absolutely. All right, Sean, what can we look forward to going into next week?
Yeah, next week we're having our first return guest, Teresa Crimmins from the National Phenology Lab, or Network, there in Arizona. She's going to join us to talk about the spring green up, how things are going nationwide as we're getting closer to spring. We're already in meteorological spring, astronomical spring, only a couple, 3 weeks ahead of us. And of course, it's been so warm in the southeastern part of the United States over the winter. So what does that mean with the threat of potential frost or freeze coming in the eastern United States later this month, and how cold it's been in the Southwest? I mean, we had snow at very, very low altitudes in Southern California recently. So we're going to talk all about those things and what we should expect regarding allergies and all that kind of stuff. So looking very forward to having Teresa back with us.
Awesome. And I think all four of us will be back next week as well. You know, it's been a wild week weather-wise, but, you know, hopefully things kind of calm down as we go into this coming week for all of us. Matt, I know you've been busy, so hopefully.
Don't count on it, I say. I feel like quiet weather just doesn't exist anymore.
Not in the Midwest. No, not in the Midwest. All right. Thanks again for joining us this week with the Across the Sky podcast. Hope you have a great week, and we'll see you next week.
August 31st, Lil Baby presents It's Only Us Tour
Made it out the treasure this type of
at Capital One Arena. Get ready for an epic summer. Lil Baby's IOU Tour has finally touched down. It's Lil Baby live in concert featuring the Kid Laroi, Glorilla, Rilo, Rodrigo, and Honcho. Tickets are on sale now at Ticketmaster.com. Brought to you by Mammoth Live and AG Touring.